simple allyl group, then you are going to get this allyl bromide as a single product. Yes. However, if you take allyl compound having two positions, see this is also one allyl group, allyl carbon, this is also allyl carbon. So what is going to happen? Yes, you can get expected this allylic position either of this side or this side, same compound you are going to get. So this is allylic bromination, allylic compound as a major product. However, during the reaction what is going to happen? Yes, so in reaction mixture you are going to get this free radical. Yes, so this free radical can be satisfied by rearrangement takes place to give this double bond and here free radical. So this position also is allylic and this is secondary. So compared to this primary center, this secondary center is more stable, right? So during the reaction, if more than one allylic position is available, then the more stable free radical which is going to be formed in the reaction mixture is going to be brominated as a major product. So this is primary carbon and this is secondary carbon. Among these two free radicals, which is more stable? Yes, secondary is more stable. So secondary carbon having free radical is going to be brominated more. So you are going to get as a major product of secondary brominated compound. Right? So this is expected is going to form as a minor product. However, since it is bromination, so it is a chiral center, you can write it as above the plane or below the plane bromination. There is no selectivity. So you can write two products. So this is very important, students. You may ask for this type of questions in exams. So similarly, just now what I said, so here also what is there? Here primary and this secondary. So already this is secondary, right? So this is also allylic to this and this is also allylic to this. However, the free radical which is formed here is going to obtain as bromo. This allyl compound is going to be formed as a major product. Similarly, if you take this, so allylic carbon, this is allylic and this is also allylic, right? So alpha 2, the next addition to this double bond containing carbon is this is allylic and this is allylic. So this is, what is the position of this carbon? This is tertiary carbon. This is secondary carbon. So when you form free radical at tertiary or secondary or primary, which is more stable? Tertiary free radical is more stable than secondary. Secondary is more stable than primary. So what we are going to get? So the major product is going to be this, which is formed at this position. This is tertiary carbon bromination. Allylic position tertiary carbon. However, this is major and the bromination which is going to take place at this position is minor product. You are going to get this is as a major product and this is minor product. So similarly, so if you take this compound, yes, there is no other chance. Here it is blocked. There is no bromination chance. So straight away you will get bromination at this position to give allylic bromination at this carbon. Similarly, it can be the NBS bromination can be used for the conversion of vitamin A1 to vitamin A2. So as you know, vitamin A1 is known as retinol. So in this is also allylic. So this carbon also allylic, this carbon also allylic, right? So this also allylic and this also allylic. So there are 1, 2, 3, 4 positions are available in this reaction or in this compound. So as I said, so vitamin A1 is going to have this alcohol. This alcohol, allylic alcohol oxidation using MnO2 in hexane, it is going to give aldehyde. So this alcohol is going to form into aldehyde. So after conversion of this aldehyde, so how many centers are there? 1, 2, 3, 4 same centers. So when you use N-Bromosuccinimide, you can expect at any of these 4 carbons. However, this carbon, since just now what I said, the carbon which is secondary carbon, secondary free radical, which is going to form secondary carbon or which is going to form secondary free radical, it is going to be get brominated using NBS to give this bromo compound, and use of this N-phenyl morpholine and heating, you are going to get elimination. Elimination is going to take place, right? So it is going to give double bond, and after getting double bond, you can do reduction with lithium aluminum hydride to reduce this aldehyde to alcohol to give vitamin A2. This is how you can prepare vitamin A2 from A1. Next, let us see some more examples. if I take this allyl compound or the double bond compound having allylic groups at these positions, right? So these two are allylic positions. However, I have taken a labeled compound. What are the compounds? You can expect these two are common, right? So this is bromine. Yes. So this allylic position, allylic to this is bromine, and this is alpha to this isotopic carbon. Other compound, what you can expect? Yes. So as usual, you can expect the bromination at this position also, right? So if I say this is A and this is B, right? This is, if I take this is give numbering as 1 here, right? So 1, this is 2, this is 1, this is 2. 2 position is not brominated, 2, and this is 3. So this is A and this is B. Then what about C? Right? So in mechanism, what is going to happen? Let us form free radical first. So this is free radical as usual, right? So if this free radical forms here, you are going to get straight away this compound. Bromination takes place at this position. Is there any question? No. So you can get straight away this compound from this. Let us label it as A, right? So here, instead of here, if it can form bromination or free radical at this also, because both are same allylic positions. So here also you can expect free radical. And if this forms, straight away from this we are going to get this, right? This is coming from NBS students. So you are going to get this bromination at this position. So you are going to get compound B. What about C? Yes. Let us see. So when this free radical is here, you can expect the rearrangement of this double bond. Rearrangement, how it is going to take place? Like this, right? So one free radical here and other free radical is here. What you can expect? Yes, you can expect like this, double bond here and here free radical, right? So this free radical, if we do bromination, that is NBS, and it is going to form this compound. So what is this? Here bromination takes place. So isotopic carbon also is going to get bromination. This is C, right? So this is how you can expect 3 compounds. Dear students, you may have doubt. So here also if you do like this, what is going to form? If you rearrange like this, it is going to form like this, right? So what is going to be formed here? Let us form like this. So this is this, right? So this is the free radical, right? So what is going to happen? Here this is, and here bromination, and this is here, right? So 1 and 2, this is also 2. So even if you write what is going to form here, so these two are same, one and the same, isn't it? So 1 and 2, 1 and 2. So this is nothing but A compound only. So how many compounds you can expect? A, B, C. So the question is satisfied. You can expect these 3 compounds in equal ratios. Nothing will happen because these are all secondary carbons. This is how allyl bromination takes place using N-Bromosuccinimide. Dear students, the bromination using N-Bromosuccinimide is known as Ziegler bromination. This NBS is commonly used for the allylic and benzylic bromination. This is allylic position, the carbon which is alpha to double bond. Alpha to double bond is allylic position. So the bromination at this position using NBS in CCl4 and peroxide as a catalyst or radical initiator, or you can use light for the radical initiation, gives allyl bromide. So this NBS is commonly used for allylic and benzylic bromination. What is benzylic position? So when you take benzene, the carbon which is attached to benzene, this is benzylic. However, if you do direct bromine for the reactions in organic synthesis, what is going to happen? If you take alkene and do the bromination by using bromine, it is going to give addition product. This is addition of bromine. Addition of bromine takes place. That means addition of bromine takes place on double bond. However, if you want allylic bromination, use N-Bromosuccinimide. This N-Bromosuccinimide gives substitution of bromine at allylic position. N-Bromosuccinimide can be prepared from succinimide. Take succinimide and addition of bromine in aqueous NaOH at 0 degree centigrade gives N-Bromosuccinimide. This is off-white solid. You can crystallize this off-white solid from cold water, and however it is moisture sensitive, and you can use it in the reactions CCl4 as a common solvent. Dear students, common reaction conditions for this reaction is use allylic compound or benzylic compound and use 1.5 equivalents of N-Bromosuccinimide in CCl4 as solvent, and radical initiator or catalyst as peroxide, or you can use light for the initiation of photochemical reaction. And after the reaction you are going to get your allyl bromide, and the bromine, after removal of this bromine you are going to get succinimide. This succinimide is usually insoluble in CCl4, so you can easily remove this succinimide. Yes students, let us see the mechanism of N-Bromosuccinimide reaction. Dear students, as I said, this reagent is commonly used for the allylic bromination. This is allylic carbon, allylic bromination. The mechanism follows free radical mechanism. So in this reaction we use, this is peroxide. Peroxide in presence of light undergoes radical initiation. This is initiation. These are all initiation steps, right? So these are all initiation takes place where this peroxide gives peroxide radical. This is radical, free radical. Initiates the slow release of bromine from NBS. Slow release of bromine takes place by the use of this peroxide. So this peroxide, the HBr which is added in a catalytic amount, or the HBr which is present in NBS itself, that initiates this bromine free radical. The obtained bromine free radical is going to initiate free radical in allylic position, at allylic position, or this proton is picked up by this free radical bromine to give HBr. This HBr is going to release bromine from NBS. So NBS releases bromine slowly with the reaction of HBr. So as HBr forms, that is going to give bromine free radical. That bromine free radical is going to form slow HBr. That HBr going to form bromine. So this bromine adds to the already formed this free radical. So this is the free radical allylic position. So this free radical allylic position is going to be brominated using this bromine. So this bromination takes place at allylic position. This is allylic carbon. In similar way, so if you take toluene, benzylic carbon, toluene, if you do bromination in presence of peroxide and HBr, you are going to get benzylic bromination. In a similar way, if you take propargylic compound, this is propargyl, and do the bromination in presence of NBS, peroxide, you are going to get propargylic bromination, right? So this is the propargylic position. You are going to get bromine at propargylic position. Dear students, so the common uses of N-Bromosuccinimide is for the bromination at allylic position, this is allyl bromide, or you can use it for benzylic bromination, or you can use it for propargylic bromination. So everyone knows that this reagent usually used for allylic and benzylic bromination. However, there are other reactions where you can use this N-Bromosuccinimide. What are the other reactions? Yes, other reactions of NBS are alpha bromination of ketones. Alpha bromination of ketones. And one more important reactions of this NBS is oxidation of alcohols. Dear students, oxidation of alcohols. And other one, it is very important, and most of the times you are going to get questions based on this. So where use of N-Bromosuccinimide in presence of nucleophiles, that means you can use it water or alcohol or HF. So when you use other nucleophiles, you are going to get addition products. These are addition products where this addition is Markovnikov's addition takes place. Where, so this double bond is going to be added with bromine and nucleophile. If you use water as a nucleophile, you are going to get this alcohol, and if you use this alcohol as a solvent or nucleophile, you are going to get ether, and this is HF, fluorinated compounds you are going to get. This addition is going to follow Markovnikov's rule. However, this addition is anti-addition. So the newly incoming or adding compounds are anti to each other. I am going to explain in detail in next slides. Dear students, N-Bromosuccinimide can be used for the conversions of these 6 reactions. However, most of the times you will come across this reagent used for the allylic, benzylic and propargylic bromination. Right? Let us see one by one with examples. This N-Bromosuccinimide can be used for the alpha bromination of ketones. So, if I take this ketone and do bromination using N-Bromosuccinimide, I am going to get this alpha position. This is alpha. Alpha to ketone group is alpha bromination takes place. However, if you want, you can make this alpha bromination even using bromine acetic acid. However, for milder reaction conditions, you can use this NBS for the alpha bromination of ketones. And if you want back of this compound, you can get it back by using zinc acetic acid reduction. Let us take, this is very important students, acid chlorides also get brominated or acid halides also get brominated using this NBS. Where it is going to brominated? Here, alpha position, right? So alpha bromination takes place using NBS. So this ethyl crotenoate. So this is ester, this is double bond, this is allylic position, right? So where do you get? Allylic bromination takes place. Here, bromination takes place at this position. Yes, students. Yes, students. So another important uses of N-Bromosuccinimide is oxidation of alcohols. Dear students, this reagent can oxidize primary alcohols into aldehydes and secondary alcohols into ketones. So if I take primary alcohol and do the reaction with N-Bromosuccinimide, it is going to form aldehyde. In a similar manner, if I take this secondary alcohol, this is secondary alcohol, and do the reaction with N-Bromosuccinimide, we are going to get ketones. So this is one of the examples where use of N-Bromosuccinimide in dimethoxyethane in presence of water, it is going to oxidize selectively this secondary alcohol only. This secondary alcohol only is getting oxidized. This primary alcohol is not going to form into aldehyde. So this is very important and specific example. These reactions were done by E.J. Corey. This is how it is going to use for the oxidation of alcohols also. Yes, students. Let us take some very important examples. See this example. So what are these? This is benzylic carbon. So this is also benzylic carbon. So in presence of N-Bromosuccinimide, benzylic bromination takes place. So benzylic bromination dibromo compound, we are going to get this dibromo compound upon hydrolysis using 1 equivalent of aqueous 10% NaOH solution. You are going to get this monohydroxy bromo compound. Dear students, use only 1 equivalent of NaOH solution. So further, upon heating, right? So what is happening? This is elimination is going to take place. So cyclation is going to take place to give this cyclic compound. This is one of the alkaloid used for pharmaceutical industry. Yes. So this is very important. So what is happening? This is alkene, right? So in presence of nucleophile, here water is taken as nucleophile. N-Bromosuccinimide reaction takes place, addition reaction. So addition is how it is going to take place. So N-Bromosuccinimide bromine is going to add at this position. Markovnikov's addition is going to take place, right? So Markovnikov's addition takes place. Hydroxy is going to come here. This is nothing but hemiketal. So hemiketal, how it is going to stabilize? So it goes out and gives this keto compound. This is very important. So acyl bromide we are going to get. So another important use of this N-Bromosuccinimide is N-Bromosuccinimide. So this alkene, cyclic alkenes can be used for aromatization, right? So aromatization, you will get aromatic compounds. How? So bromination, allylic bromination gives allyl bromide. Here this allyl bromide upon cyclic allyl bromide upon elimination, you are going to get this double bond compound, right? So allyl bromide, here you are going to get elimination compound to get this double bond compound. This double bond, see this is allylic position, isn't it? So this is allylic position, this is also allylic position. Either of the two, you are going to get bromination on these carbon. Further elimination, you are going to get benzene. The exception of these reactions is, one of the exceptions is, so N-Bromosuccinimide in presence of tetra-alkyl ammonium chloride, for example tetrabutyl ammonium chloride or bromide, you are going to get addition reaction. So in presence of tetrabutyl ammonium chloride or alkyl ammonium halides, you are going to get addition products. So the addition is trans addition, trans bromination takes place. So this is very important, students. In presence of, if you see tetra-alkyl ammonium halide, write this addition product. If not, do as usual bromination, allylic bromination. Another important use of this N-Bromosuccinimide reagent is oxidative decarboxylation of alpha amino acids. So these are amino acids. Alpha to this acid is alpha position alpha amino acids. Alpha amino acids upon reaction with N-Bromosuccinimide are going to form these imines. So what is going off? One carbon less imine is going to be formed. So this carbon is going out as minus carbon dioxide, right? So minus HBr. You are going to get this oxidative decarboxylation of alpha amino acids. This is how N-Bromosuccinimide is very important reagent in organic synthesis. Similar to N-Bromosuccinimide, N-Chlorosuccinimide also can be used for the chlorination. So most of the reactions are similar to this reagent. N-Bromosuccinimide and N-Chlorosuccinimide react similarly. However, so N-Bromosuccinimide gives N-bromo compound, N-Chlorosuccinimide gives chloro compound. Yes students, let us see addition of NBS and alkene in presence of nucleophile. This nucleophilic addition is addition reaction. When you do the NBS reaction in presence of some nucleophile, the common nucleophiles are water, or alcohol, or HF. So when you use these nucleophiles, the addition takes place. Dear students, addition is Markovnikov's addition. How? Let us see. So Markovnikov's addition, so the bromine adds to the carbon which is attached to more hydrogens, or this is, if I add bromine here, so what I am going to get, this is the secondary carbocation. Secondary carbocation is more stable. If I add bromine to this carbon, and here I am going to get positive here, this is primary carbocation which is not stable compared to this secondary carbon, or less stable with compared to this secondary carbon. So during the addition reaction of this NBS, it follows Markovnikov's rule to give this bromination. Bromination takes place at this carbon, where the intermediate is going to give secondary carbocation. This secondary carbocation forms this cyclic bromonium ion or cyclic bromonium intermediate. This bromonium intermediate, yes, when you add nucleophile, it opens up like this to give bromine and nucleophile here. So what are the common nucleophiles? Yes, it can be OH or it can be alcohol. For example, methanol, if I use OMe, or if I use HF, it is going to give fluoride. So let us solve some examples. So if I take this alkene, right? So what is the common intermediate, or where bromine going to attack? Here or here? Addition takes place. So if I add this here bromine. So what is the intermediate? Yes, here carbocation is going to form here, where this is secondary carbocation or tertiary carbocation which is more stable. So first bromine adds here and gives intermediate of this, right? So carbocation, and the nucleophile here it is OH, it is going to attack from here and to give so trans to this bromine. So what is the product? So this is the product. It is not going to add at this carbon, right? So because it is Markovnikov's product. So let us see this NBSHF, right? So you can add bromine here and here fluorine. Straight away you can add addition product here also. So don't confuse. This is propargylic alcohol, propargyl alcohol. So imagine this, it is an alcohol and this is R group. So what is going to happen? Yes, you can add bromine here and here O, and straight away write the remaining compound. So this ether you are going to get. Similarly, what is going to happen? So bromine. So here it is going to form carbocation. It is going to be stable. So you are going to get bromine here and here methanol. Since we are using methanol, so we are going to get this methyl acetal, right? Here what is going to happen? Here also we are using alcohol, and this is very important. Similar to this, what is going to happen? Bromine going to attack here, right? So bromine is going to be formed here, and remaining what is going to happen? Yes, it is going to form alcohol, right? So this is a carbon and here one carbon, and remaining is going to be intact. So this is the product we are going to get. This is how addition of bromine takes place in presence of nucleophile. the addition follows Markovnikov's rule, and the product what we are going to get are anti to each other, or trans addition is taking place. Yes, students. So N-Bromosuccinimide in presence of nucleophile undergoes Markovnikov addition reaction, and this addition gives trans addition, right? So for example, the starting material is trans compound and do the trans addition. This is trans stilbene. Do the trans addition, right? So what we are going to get? This is the compound. So if you rotate like this, so what is going to have? Right? So this is CC bond. This is nothing but trans compound, trans addition. It is going to get syn, or here you have to say same side erythro. So pair of enantiomers we are going to get. What is another pair? Yes, you can expect this also, right? So bromine and here hydroxy. So this is how you can expect these two are erythro compounds. Here these two are enantiomers to each other. Dear students, it is very clear. Trans starting material, trans addition, erythro compounds. There are other reactions where you can expect similar products. So let us take some addition products or addition reactions. Syn addition. Yes, you can do syn addition using osmium tetroxide dihydroxylation. So osmium tetroxide is a syn addition reaction. KMnO4 dihydroxylation or oxidation is syn addition product, syn addition reaction, and Woodward dihydroxylation also is syn addition. Whereas addition of bromine is trans addition. Similarly, N-Bromosuccinimide in presence of nucleophile gives trans product or trans addition takes place. Previous addition also is a trans reaction. Dear students, it is very clear. So addition is trans addition. The product what we are going to get depends on the starting material what we are taking. Let us see some examples. Let us see alkene. It can be cis. So what is alkene? Cis alkene. For example, cis stilbene here, right? Cis stilbene, and this is trans stilbene. Clear? So if I take this cis and trans, based on the substrate and the reagent what we are going to use, whether it is syn addition reagent or anti-reagent, the product is going to be, we can expect which stereochemistry we are going to get. For example, if I take syn substrate, this is the syn substrate or cis stilbene, and do the syn addition. Syn addition common reactions are osmium tetroxide. Let us take osmium tetroxide. So what we are going to get? Osmium tetroxide. It's a syn addition. You are going to get this syn product. So this is syn product. This is nothing but erythro. Same side. Two groups are same side. So erythro. Since it is symmetric, plane of symmetry is here. So this is a meso compound. Right? So this is a meso compound. If instead of here phenyl, if it is having methyl group, yes, you are going to get pair of enantiomers. What are the pair of enantiomers? Other enantiomer what we are going to get is this. Addition can be above the plane or below the plane. This is how you are going to get. So pair of enantiomers. If it is symmetric, if it is stilbene, cis stilbene, you are going to get meso because of presence of plane of symmetry. Or if you take different, this is a styrene like compound, or you are going to get this pair of enantiomers. Similarly, if I do the anti-addition, for example, same cis stilbene and anti-addition. What is anti-addition here? Yes, N-Bromosuccinimide anti-addition. So what we are going to get? Addition. So we are not rotating anymore. So anti-addition, here we are going to get this anti-addition. So trio compound. What we are going to get? Here, see, this example is trans example. Here if I take cis example, what we are going to get? So this is the product. So this is trio. Two groups are opposite to each other, right? So here phenyl, phenyl. So here bromine, and here OH we can expect, right? So these are pair of enantiomers. It is very simple, student. Taking syn starting material, doing syn addition like osmium tetroxide dihydroxylation, you are going to get meso compound or pair of enantiomers. If the starting material is syn, same cis compound, and do anti-addition, for example NBS nucleophile, you are going to get trio compound. This is trio compound. Syn starting material, anti-addition, trio. However, if you take anti compound, right? So this is anti, this is trans stilbene, and do the syn addition. So here it is very important. So do the syn addition. So what is happening? Syn addition, for example, osmium tetroxide, right? So syn addition, if it is like this, so syn addition OH, right? So here syn addition OH means both are coming from above the plane. So when you rotate this CC single bond, you are going to get this here it is same and here it is below the plane, right? So this is 3O product you are going to get, 3O compound, anti-starting material, syn addition, 3O compound. If anti to anti addition, so this is the reaction. So anti to anti addition, what is going to happen? Here you can write, so anti phenyl here, this is phenyl. So what we are saying? Anti addition, this is bromine and this is hydroxy. When you do the rotation of this single CC bond, you are going to get, so when you bring this phenyl here, this phenyl is intact, the bromine is here same, and this hydroxy also is here coming, right? So anti addition, pair of enantiomers, same side, anti to anti, same. So sum up, what is happening? Yes, syn giving erythro, right? Anti giving erythro, syn anti, right? If it is anti and syn, you are going to get 3O. So this is the way addition takes place, and based on the addition, the stereochemistry can be explained. Dear students, this addition, so please note down. So syn gives erythro, syn anti gives 3O, right? So erythro, the hint to remember erythro is same side. See, in erythro you write like this, E. So E is same side. So you can remember erythro compound, adding compound or the addition takes place from the same side to give this erythro compounds. T is opposite of this. So T gives addition from opposite, or the product is going to give trans products. Dear students, so just now what I said, syn plus syn addition, same gives erythro, right? Whereas anti plus anti addition also gives erythro, isn't it? So anti gives erythro and syn gives erythro, whereas cis, syn and anti addition gives 3O, and anti starting material and syn addition gives 3O, right? Let us see the examples. So this is cis 2-pentene. Upon bromination, this bromination is anti addition, isn't it? So cis compound anti, what we are going to get? It is 3O compound. So what we are going to get? Opposite. The adding bromine gives two opposite directions, right? So anti 3O compound we are going to get. So this 3O is pair of enantiomers. Similarly, if I take the trans starting material, trans 2-pentene, right? So trans 2-pentene upon bromination, that is anti-bromination. So trans addition gives, so syn product or erythro, pair of erythro isomers. So this is syn isomer. So bromine is same side. So these two are mirror images. So pair of enantiomers. So this remembering of this addition product, you can back check also. For example, if you take this trans compound or 3O compound, do the debromination. So elimination, how it is going to take place? Trans elimination. So this bromine goes up, right? So trans elimination takes place to give this bromination, right? So two bromines are going to undergo trans elimination to give cis product, right? So cis product, back reaction bromination, we are going to get this, right? So syn product, you are going to get this anti addition product, that is 3O. So this is a short trick. Let us see some specific examples under N-Bromosuccinimide, which were asked in so many entrance exams, and very important examples we are going to see. Let us see. Yes students, Let us see some specific examples. So the starting material is allyl alcohol. This is nucleophile. Don't confuse with this nucleophile. This is nucleophile and this is alkene. So the starting materials are this is alkene. So NBS in presence of, so think that this is all is alcohol. Some are OH. So alcohol is a nucleophile and this is alkene in presence of NBS. Addition takes place. So this alcohol is adding to this double bond. So Markovnikov's addition takes place to give this intermediate. This intermediate upon reaction with tributyl hydride in presence of ABN gives this cyclic compound. What is happening? So free radical reaction, it is going to take place like this to give this cyclization product. So this is the product. So the mechanism follows like this. So N-Bromosuccinimide adding to this alkene, ethoxy alkene, to give this addition product bromonium ion. So the addition is Markovnikov's addition. Now what is happening? Here it is coming and here it is going out. So to give this bromine and here to give this intermediate upon reaction with ABN in tributyl hydride in presence of ABN gives this cyclic product. Let us take another example. This is very, very important, students. Intramolecular cyclization is taking place. Intramolecular. What is there in this reaction? So alkene is here and alcohol is here. So allyl positions also are here. N-Bromosuccinimide and dichloromethane. This is DCM is nothing but dichloromethane is a solvent for N-Bromosuccinimide reactions. So dear students, so what is the position? So 1, 2, 3, 4, right? So here 1, 2, 3, 4. So alcohol or this position is here in product. Where is the double bond? So this is here, 3, 4. So 1, 2 double bond here, 4, 5, 6, 7. So 1, 7 double bond it is. So this migration is taking place. How? Let us see. So in first step, the bromination, as usual, bromination is taking place to give this bromonium ion, right? So this bromonium ion cyclic intermediate is addition is taking place, anti-addition, right? So anti-addition is taking place to give this compound. So the anti-addition is taking place at this position. This alcohol is adding to this position and these two adding compounds are anti to each other. So this compound upon elimination, right? So this here elimination is going to take place at this position to give this double bond compound. This is very, very important, students. This is how N-Bromosuccinimide can be used for nucleophilic addition reactions also.